Hi everyone, I'm Jeremy and welcome to my channel. Today we're gonna deep dive in the world of microcontroller. We are going to build a real-time voice assistant powered by OpenAI Real-Time API and Langchain. So let's go! Hey, can you hear me properly?
Yes, I can hear you properly. How can I assist you?
Awesome. Can you get the news about the box game between Tyson and Logan?
Sure, let me check the latest news on the boxing match between Tyson and Logan for you. I'll ask my friend Tavali for help. It looks like there was a recent boxing match between Mike Tyson and Jake Paul, not Logan. Mike Tyson faced off against Jake Paul, and after 8 two-minute rounds, Jake Paul won by a unanimous decision. The judges scored the fight 80 to 72, 79 to 73 in favor of Jake Paul. If you're looking for more details or updates, I can help you find specific.
Okay, that's fine. Thank you for this information. Have a good day.
You're welcome. Have a great day.
Okay, so as we can see, the ESP32 is able to hear us because we can see the red lights blinking. And as we can hear, the ESP32 is able to speak to us thanks to the speaker. So let's go to the code part now. Okay, so first let's have a look on the required material and hardware for the project. So of course, first of all, you need an ESP32 board. This one is a S3 room model. You'll need a bunch of jumper, you'll need a USB cable to connect to your computer. You may want to buy one button to activate and deactivate the microphone input. This microphone here is a INMP 441 microphone. It's like $2. This one is the amplifier here. So just so that you know, you will probably need to do some soldering around here. So get your soldering stuff ready. Up, I'm gonna put it back. Of course, we got two resistors here for the LED, and we got also this red and this blue light. It will be very useful when you want to debug your program and you don't know if the sound is properly received or not. And of course, to finish, we got this speaker, which is a very basic, I think it's a 3 watt and 4 ohm impedance speaker. So yeah, that's about it. You can get a bunch of additional resistors if you need. And of course, a development board, a breadboard, so that you can tinker easily with your different with the different parts. Okay, so now let's go to the code. Okay, great. So let's start with the code. So you may not know platform.io, but you will need to install it. This plugin is very useful if you want to program with IoT. So the first step is to install it. So go to your extension tabs and just type platform.io. And then you will see that you can install this VS Code plugin, and of course it's working also for Cursor. So yeah, once you installed your platform.io project, you can create a new project. You can call it anything, assistant AI for example, and you will select a board. So the easiest way to start is to choose this the board that fits with your material. So it will depend on your on the kind of board that you're using. But let me find it. But usually Espressif ESP32 dev module is working quite nice. Also, I will be adding in the commentary a specific JSON for the S3 room because I could not find a configuration file. So, but I found a nice internet person that put a JSON that you can add. So just check the commentary if you are stumbling with these issues. Okay, so now we got our board ready. Let's take anyone. framework, you can keep Arduino, and for location, you can just choose the location that you need. So once you create and finish, it will then create a new project for you. And as you can see here, hopla, I can see my, my code, and it's organized in a workspace. And I can see here the code specific to the ESP32. What you will notice here is the configuration file, because with every project made on platform.io, you got this platform.ini file. It's very useful if you want to add libraries, and we will do it later in the project. So I will just leave it here for now, and here is the JSON file that I've been talking to you about. So yeah, hopefully you got your platform.io ready now, and you can see the different options that you get to build and start your project on the device. Okay, cool. So now we have seen how to receive the microphone input and how to send it to our program and to our via WebSocket. Now what we're gonna see is how we received the WebSocket from the WebSocket server and play it through the speakers. So let's have a look. Let's have a look at it. So as you remember, we have this WebSocket library, and in this WebSocket you define two very important things: the on event and the on message. On message will be called every time that your WebSocket, so the Node server, will be sending data to our ESP32. So here we do a bunch of checks to check if the sound is properly binary and if properly existing. And if it does exist, we just play it to the speaker using this function speaker play that will rearrange the pitch and the volume of the speaker. So this is very useful. Let's say if you got some neighbor and you want to work late, but you don't want your speaker to be too loud. And the pitch also is useful if you got some pitch issues. So yeah, as you can see here, it will just write the buffer to the speaker, and it should work. You should hear the sound coming from your agents to your ESP32 speaker. So that's quite basic, but as you can imagine, there was a lot of issues, because when you don't hear the sound, you cannot be sure that it comes from the hardware part, from the ESP part, or from the Node part. So yeah, maybe you will lose some hair on this part, or maybe it will go just fine. But yeah, basically that's it. So our WebSocket will just send the buffer that it received to the speaker. So that's it for the ESP32 part. As we saw the architecture with the different library, we saw the main function that is orchestrating all our elements together. And now what we're gonna do is we're gonna add some intelligence to this assistant. So let's go on the Node server part. Of course, you can do it in Python if you prefer, where we will plug the OpenAI real-time API and our Langchain stack to the ESP32. So before we jump on the server-side Node.js code, I want to bring some information about this platform.io.ini file. So here you can see the type of board, the monitor speed. This is maybe something that you will have to adjust if you see that the log are really strange. The monitor port, usually it's working as automatic, but for me it was working like this, so I kept it. And the library dependency here. So we installed this library already, but if you want to install more, you can just click on platform.io home. And actually here, if you go to the library tabs, you can type anything. Let's say, I don't know, like WebSocket again. Up, and you can find some nice libraries that you can easily add to your project just by selecting your project and clicking add. As you will see, it will add a new line in the libdepth slot. Okay, so that's cool for it. Now we want to upload and monitor our code and see if it works or if it fails. Actually, it should be able to build, but it should fail at connecting to the WebSocket, because of course the WebSocket is not connected yet. So let's see how it goes. Okay, so it's building stuff, compressing stuff, writing stuff. Usually it takes like 20 seconds. Okay, so our Wi-Fi is connected, we got an IP address, but the socket is failing, which is totally normal. So let's go fix it and let's go create our node server. Okay, so let's switch folder. Let's go to ESP32 and let's go to server Langchain. You guys can check out the server. It's basically a simpler implementation because it's not using WebSocket for. It's not using the real-time API of OpenAI, but it's using the audio API, which is very good because you can do speech-to-speech, for example, which in our case will be great. But right now we're directly gonna dive on the Langchain server. So first let's have a look on the package. So we got a Hono node server and WebSocket, a bit of Langchain, a bit of audio decode, clipboardy, which was useful because I wanted to copy something on the clipboard, and Zod and the wave library. Don't forget to add the types for wave because it's not here by default. So let's go ts6wat src index.ts. So as we can see here, it's basically where we will set up the WebSocket server and the eventual app or monitoring path, which you can combine, of course. So this is for the HTML path, HTTP path, and this is more for the WebSocket path. So if we don't have an OpenAI key, we just close it because it won't be good. Here we have an array of connected clients. So every device that will connect, we will be able to send them back some data. So actually, this will be a function that we will see at the very end because it's broadcasting to clients, meaning like this will transfer back the audio that we received from OpenAI to the ESP32. But let's start with the beginning. So right here we created an agent, which is an OpenAI voice React agent. So this is based on the work by Langchain of a repository called React Voice Agent that you will find the link in the description. That I've been refactoring a bit in order to make it fit my case, which was just a bit different, but overall the same. So let's go. Well, let's have a look on the OpenAI Voice React agent. So basically here you get some instruction that you can send as a system prompt. You can send your tools. So here we will send Tavily and a simple tool for additioning number. So Tavily will be really helpful for giving some internet connection to our LLM. The model will be GPT-4 or real-time preview, which is the model that is working with it actually. The audio config, so I'm quite not sure. The original sample rate from OpenAI is 22K. From the ESP32 we are receiving 100K sample rate, so I'm a bit confused about it and what's working and what not, but I just so you can try to adjust the sample rate if it's not working on your case. So okay, here we just wait a bit for the connection to resolve, and then we got our big bunch of code here, which is the agent connecting and transmitting sockets. So as you can see here, I'm not gonna go too much into details because I think you will need some time to read it and download it and try it and tweak it on your side. But basically, what it does is that it will send an instance of our WebSocket, and it will send a callback for the output chunk. So as we had seen before, the callback for our output is a broadcast to clients. And one thing to note here is that we don't send directly the whole chunk. we split it into 1024 bytes packets to be more gentle with the ESP32 RAM. What we could do if it was still too much is to add a small delay here, or even reduce the chunk size. But if you reduce it too much, then the audio output will not be as good as you want. So okay, let's go back to our agents. So up, I'm trying to find the connect function. Okay, so we got our connection that is initialized here. First, it will connect to the OpenAI API and forward the call up. Then it will define our tools, thanks to the tools that we have defined previously. And here it will be the first event that we will send to our OpenAI real-time API. It's session updates. It's kind of an initializer of session. So we say, we send the instruction, we give the model that we want to use for the audio transcription, the tools that we want to use, and the audio input and output format. Okay, so that's it for the initialization of the connection. Okay, so let's dive into this connect function and see how it will orchestrate the input stream and the output stream and the button trigger. So the connect here will first declare an input stream. Here we will declare our input WebSocket. And what we will do, so we wait for the WebSocket to be open, we define it as the array buffer. Here is what we will receive from the microphone. And we set up a binary message handler, meaning like, so every time a message is received here, we check that if it's an instance of a buffer or of array buffer, and if so, we handle the incoming audio. So yes, here we will handle the incoming audio as buffer, so we will go to our audio manager. So let's have a look first on the audio manager. So basically this class is here to implement everything that is related to file, to wave, to changing of pitch, or any audio operations that we will need. It's used to process and write the buffer. It's used also eventually if you want to use a buffer and add some gain. If, for example, your microphone is very low, but unfortunately, if you will add some gain, you will get some crisp on the sound, and it will not sound as good. So yeah, let's go. Let's have a look on the function that we want to check. That is the handle audio buffer. Up. So what we do here is that we defined max buffer size, meaning that anyway, if the buffer, if the audio buffer is bigger than this, we will write it to file, to not just having a huge temporary buffer. And so anyway, what we will do here is that we will concatenate our existing audio buffer with the new buffer that is received via WebSocket. Similarly, we will have a timeout to write the buffer every 0.5 seconds, every half second, for example. And yeah, that we will see here. And so if the buffer is too small, we will not write it, but once it's above the minimum threshold of the buffer size, and that it's not already processing, so yeah, we process and write buffer. So basically what we do here is quite simple. We just basically check that the audio buffer exists, that it's not processing, and then we write to the file the buffer that we have, and we clear the buffer. So we saw how we are handling the input buffer. Now we're just gonna check two things: how we start and how we stop the recording. So the start recording session, it's triggered when we receive from our stream an input of type text, which is equal to start record. If you have a look at the code, you can notice that start record is sent via the message here in the C++ code when we press the button. So this is how we manage our stream, which are merged into a single stream. And we release this function that you can find in the utils which is called merge streams here. So it's useful because it makes working with only one stream rather than many. So now we go back to the close stream function. Hopla. So the stop recording and process audio, what we will do here is, of course, we will set recording to false. We will close the file. We will get the current buffer of the audio manager. And what we will do here with the buffer, we will convert it to a proper PCM says that is okay for OpenAI real time. So what you will need to do here is to adjust depending on your source rate and on your target rate. This will allow you to get a predefined frequency from any input frequency. Now that we get our base 64, we send it as an audio event to our real-time API. So the events that you will send to the real-time API of OpenAI are JSON that you need to send via WebSocket. So as you can see here, we got this connection handler, which is our OpenAI WebSocket connection that manage the connection to the OpenAI real-time. And we got this send event. We will basically just stringify the event that we want to send and send it as a WebSocket to OpenAI. So that's it. Now we know how we start the record, how we stop the record, and we know how to handle the buffer in between. And we know how to send the event to our OpenAI real-time API. So now for the last part, let's have a look on how to manage the outputs that we received from the
So now let's
have
have
a
a
look at this handle speaker response
output
here, which is called by handle stream output. As you can see here, so this function, what it does here, it's that it gets the audio delta that is sent from the WebSocket, because OpenAI will not send us any buffer. It will just send us a base 64 representing the buffer. So once we get this delta here, we just stringify it and send it as by our callback that we defined previously. And yes, that's about it for the overall architecture of this Node server. As we saw earlier, the broadcast to client is the callback that we will send the base 64 parsed as a buffer to our ESP32. So you can have a further look at the code and see how the voice tool executor and the connection work. And if you got any, if you want to get a Python implementation, you will find the link in the React voice tool made by Langchain that I will put in the description again. So yeah, now let's just start it and let's see if our ESP work. Okay, so now we got our C++ code, our server code is ready, we got our device that is plugged to the computer, everything is plugged, the microphone, the amplifier, so let's go ahead and build it via platform IO tool, upload and monitor. So this will send the firmware to the device, and we will see that the WebSocket should be connecting as we launch our WebSocket on the server Langchain side. So let's just wait for the ESP32 to finish the connection, to finish the build. So it's connecting to Wi-Fi, the IP address is here, and the WebSocket is failing. So let's run it. And it should be retrying. Okay, so now we got our connection open, our WebSocket is connected, our I²S is initialized successfully, and the microphone also is initialized. Hello, can you hear me? Hello, can you hear me?
Hello, yes, I can hear you. How can I assist you today?
Can you tell me the news in the tech world of today?
Sure, let me check in with my friend Tavali to get the latest news in the tech world for you. Please give me a moment. Here are a few highlights from the tech world today. One of the big stories is about Microsoft and OpenAI. It seems Microsoft is ensuring they won't be caught off guard by any unexpected changes in OpenAI's board, especially if Sam Altman, the former CEO, returns. In other news, the gaming world is buzzing as the popular game Death Stranding is coming to select Apple devices on January 30th. Also, Tesla is reportedly building a compact crossover vehicle codenamed Redwood. If you're interested in more details or other stories,
Oh, cool. Can you give me more information about that last Tesla truck? Is it a truck or a car or what is it like?
certainly, the compact crossover Tesla is reportedly working on, codenamed Redwood, is expected to be a smaller version of their current SUV lineup. It's not a truck, but more of a car-SUV hybrid, aiming to offer the benefits of an SUV, like more space and a higher driving position, but in a more compact, efficient, and potentially more affordable package. This type of vehicle would be ideal for urban environments and would appeal to customers looking for a stylish, electric, and practical vehicle.
Okay, interesting. Do you know the price tag for this car? Can you do a research for it?
As of now, I don't have information on the specific price tag for Tesla's upcoming compact crossover, Redwood. Pricing for new Tesla models often stays under wraps until closer to their release. However, we can certainly search for any recent updates or rumors about the vehicle's pricing. Let me check in with Tavali for more information. It looks like the Tesla Redwood compact crossover is aiming for an affordable price point. The latest reports suggest that Tesla is targeting a price of around $25,000 for this vehicle, which would make it quite competitive in the electric vehicle market. Do keep in mind that initial launch editions might be priced higher, with the cost settling into this range in subsequent model years. This move seems to align with Elon Musk's vision of offering more budget-friendly electric options.
Okay, interesting. Well, I got to finish my video, but thank you. I will get back to you if I need anything.
You're welcome. I'm glad I could help. If you have any more questions in the future, feel free to reach out. Have a great day.
So I hope this gives you a bit of vision on what it can do. Of course, you can adapt it to your needs, be it a language teacher, startup coach, business advisor, a health advisor, a life coach. You can do anything from here, as you can plug it with any custom function. Okay, so this demo is over. Hopefully you had it was an interesting moment and you learned something either in CPP or in WebSocket. Anyway, for me it was very interesting to build this. First I discovered a new language, which is C++, which was a big miss for me, but which is okay. The hardware part was a bit of a hassle at the beginning, notably with the ironing and soldering, which really needs to be done perfectly. And of course, the audio frequency, all this was really something that got overly complicated. But anyway, it's a great experience. I'm sure that there is a lot of use for this connected objects, connected with some really advanced AI agents, like the ones that Langchain allows us to do, with RAG. So I think you can imagine pretty much everything, because then the user doesn't have to stick with his computer or with his mobile phone, so it's new usage. And yeah, so basically I can just it's Wi-Fi, so you can connect anywhere. So yeah, let's just see what you can create with it, and see how we can build something cool. Okay, talk to you soon. Bye bye.